Welcome everyone. In this lecture, brief lecture I should say, we just want to discuss transformations of power functions. We have already discussed transformations extensively in the past, but this is only a short note on power functions. So if you have, let's say, a cubic function, y equals x cubed, this is the basic parent function, then it may undergo some transformations, and the equation of the transformed function would be in the form of y equals a times k times x minus d all cubed plus c. Please note that k is inside the brackets and it has to be raised to the exponent of 3. Now, generally speaking, not always we have a cubic function. You may have a quartic function or quintic function. So for any power function of the form y equals x to the exponent of n, we have this equation y equals a times k times x minus d inside the brackets raised to the exponent of n plus c, which would be the equation of the transformed function. It says describe the transformations that must be applied to y equals x cubed, the basic cubic function, to graph g of x, which is this transformed function. It's a complicated cubic function. The first thing we do, as we have always done in the past lectures, is to find the values of a, k, d, c. So here a is negative 2, k, we have to find out what it is. You know that inside the brackets we have to write it in the form of k times x minus d. So we have to factor k out before we decide what k is. So I'm going to factor 1 over 8 out. So we get x plus 32. And this is what is actually inside the brackets. If you multiply 1 over 8 by the bracket, you get exactly the same results we have at the top. So we have to always be careful. Instead of giving the question in this form, they may multiply and give you the answer, give you the equation of the function in the form of 1 over 8x plus 4, and then you may have a hard time finding the value of k and finding the value of d. So here, the d value is actually negative 32, and k is 1 over 8. So some students, by mistake, they think the value of d is negative 4. Okay, but they see this negative 4, but they don't realize that 1 over 8 must be factored out first. So we have to write it in this form. Okay, so the value of k is 1 over 8, the value of d is negative 32, and the value of c is negative 7, of course. So these are the AKDC values. We can write the mapping rule as we have done always in the past. So it's going to be x over k, which is 8x, plus d, which is negative 32, and then ay, which is negative 2y, and then minus 7. So this would be the mapping rule for this cubic function. So if we have the table of values for the parent function, for the basic cubic function, then we can find the x and y values from there. We're going to extract those from there and plug in our mapping rule and come up with the images of those points which are on the graph of the parent function, but this time on the graph of the transform function. The names of the transformations involved here, we will start with the vertical stretch. So I'm going to write, we have a vertical stretch or expansion by a factor of 2. Then inside the brackets we have 1 over 8, so we have a horizontal stretch or expansion by a factor of 8. We say by a factor of 1 over k, that is 1 over 8, which becomes, of course, 8. And then we have reflection. So after we're done with the stretches and compressions, we go after reflection in the x-axis. This is because of the fact that a is negative, okay? And then we're going to have a horizontal translation or shift by 32 units to the left, horizontal translation by 32 units to the left. That's because of the D. That's the effect of D. If D was 0, then you would not have this 32, you would not have that 4, and the graph would not be horizontally translated or shifted to the left by 32 units. And then we have one more, and that's vertical shift or translation, 7 units down. So that's the fifth transformation. So there are 5 transformations involved in this cubic function. And whatever we said for cubic function is also true for quartic function, quintic function, and generally speaking for power functions of degree n. So I'm not going to draw the graph here, but as I said, if you grab these x and y values, plug in here, you will end up with another table of values, and then easily you can plot those points and draw a smooth curve passing through those points, and that will be the graph of this complicated function g of x. We have done enough examples in the past, that's why I don't draw the graph, but as I said, it's not a big deal. You can do it. You just plug in -2 for x, then that becomes -16. -16 minus 32 would be -48, and then you plug in -8 here, times -2, that's 16, minus 7 would be 9. So there you go, that would be the coordinates of the first point you plot, and you repeat this for 5 points, and then at the end you just draw a smooth curve passing through those points, and that would be the graph of g of x, which is the transformed function. Okay, so one of the key things you just have to remember is that k is always inside the brackets. Okay, so k has to be raised to the power of 3, just like here 1/8 has to be raised to the power of 3. So it's not like it's outside. Okay, thank you, and keep practicing.